let's look at another simple operation that you can do with matrices. Multiplying a matrix by a real number. Also, we call this as scalar multiplication. Okay, suppose you have a matrix A, which is just a grid of numbers. So let me take my A as, let's say I have 1, 2, 3, 4. So this is a 2 by 2 matrix. So here, let's say we want to multiply this matrix with another number. Let's say the number is 3. So here you have to understand this is a matrix and this is just a number. This is a scalar. So now you're asked to multiply this constant C with this matrix A. So how do we multiply? So to multiply matrix A by C, that means you have to multiply every single element in matrix A by this constant C. So that means your new resulting matrix will be just you take each entry and you multiply it by 3. So if you multiply 1 by 3, you get 3. If you multiply 3 by 2, a 6, 3 by 3, a 9, 3 by 4 as a 12. So this is how you do the multiplication. So the matrix B is equals to 3 multiplied by A. So this is how you do a matrix multiplication with a scalar. So let's try some examples. Okay, so here we have a 2 matrix. Okay, let's say you are asked to multiply matrix A by another constant 2. So to get this new matrix, you have to get each element in this matrix and you have to multiply it by 2. So it's very simple. So the first entry is going to be 4. This is negative 2. If you multiply negative 1 by 2, it's a negative 2. 3 by 2, it's 6. And then 5 by 2, a 10. Negative 8, 4, 2, 8, negative 4. So this is your new matrix. Next, let's say you're asked to take 3 multiplied by matrix B. So that means again you're asked to take each entry and you have to multiply it by 3. So this is 3, 9, negative 6, 12, and then 18, 3. So this is your new matrix. So quick summary. So when you're multiplying a matrix by a number, just multiply each entry by that number. So this is called scalar multiplication. So it's just like stretching or shrinking all the values in the matrix by the same factor. So that's how you do a matrix. That's how you multiply a matrix with a number. Okay, so now let's talk about how to multiply a row matrix by a column matrix. Okay, first question, what do you mean by a row matrix or column matrix? So row matrix means it's a matrix with just one row with multiple columns. For example, let's say you have row matrix R as 1, 2, 3. So this is a matrix again, and here we have only one row with 3 columns. So this is a matrix of this format we call as a row matrix. And let's say you have another matrix, a column matrix. The column matrix, let's say I'm going to take it as C. For a column matrix, you have only one column with multiple rows. So let's say I have 1, 3, 2. So this is an example for a column matrix. It's because you have only one column with multiple rows. So now let's try to understand how do we multiply two matrices like this, a row matrix with a row column. So here notice that this is a row and this is a column matrix. So when the next question is, when can we multiply them? So for example, in this in this row matrix, you have only one row with 3 columns, and on this column matrix you have 3 rows with 1 column. So the product will be a 1 by 1 matrix, which means it's going to be a single number. So here you have to notice the number of uh, columns in this matrix is 3 and number of rows in this matrix is 3. So you can only multiply two matrices together only if the number of columns in the row matrix matches with the number of rows in the column matrix. So next question is, how do we multiply when we have a row matrix and a column matrix? So when you do your multiplication, so let's say you're interested at getting multiplying R and C. So you have to multiply R and C, and you can do this multiplication. It's because the number of rows, number of columns in this R matches with the number of rows in this matrix. So when you're doing the multiplication, what you have to do is you have to multiply the numbers in matching positions. So you have to multiply numbers in the matching positions and then you have to add them together. So okay, let me write this. So you have to multiply R and C, which means I'm going to write my R first, which is 1, 2, 3, and then I'm going to write my column, which is 1, 3, 2. And your answer will be it's not going to be it's not going to be a matrix, it's going to be a single number. To get this single number, you have to multiply the matching position, and then you have to add them together. So matching positions are like, you have to multiply 1 by 1 the first entry in the row matrix with the first entry in the column matrix, and then you'll end up with 1. And then you have to multiply 2 by 3, which is going to be 6. And then you have to multiply 3 by 2, again a 6. And finally you have to add all numbers together. You'll end up with 13. So the answer, when you multiply a row by a column matrix, you'll get a single answer, a single number. And in this case, you'll get 13. So this is how you do. So let me wrap this up again. So if you have a row matrix, let's say the number of columns in that row matrix is n, and you have another column matrix with n by 1, which means here the number of rows is n. In that case, you'll end up with a matrix, a single matrix, if you multiply the two matrices together. So multiplying the entries 1 by 1, and then you have to add them together to get the answer. So this is also known as dot product in a vector math. Okay, so let's try some examples. Okay, so here you are asked to get the product of a matrix. So this is a row matrix and this is a column matrix, and you're asked to multiply. And here you see that if you consider this matrix is with one row with 3 columns, and the second matrix we have, it's with one column with 3 rows. So that means you're allowed to do the matrix multiplication here. So if you multiply them together, you'll get a single answer, single number. So to get that single number, you have to do this multiplication. 5 by 0. If you do the simplification, if you multiply the two numbers together, you'll get a 0. And then you have to multiply 1 by 2, which is 2. And then you have to multiply 2 by 1, you'll get a 2. And finally, you have to add these three numbers together. So you'll get a 4. Moving on to the next example. In next example, this is a row matrix with 4 columns, and this is a column matrix with 4 columns. So the numbers match. So you can do the matrix multiplication here. So let's multiply the numbers together. So 2 by 3, it's a 6. And then 3 by 2, another 6, 7 by 0, a 0, and then you have to multiply 1 by 1, which is a 1. So you have to add these four numbers together. 6 plus 6, a 12, 12 plus 0, 12, 12 plus 1, a 13. So remember, if you have two matrices, a row and a column, and you are asked to do the multiplication, your answer will be a single number. But remember, when you can do this multiplication only if the number of rows in the number of columns in the row matrix matches with the number of rows in the column matrix. Okay, so now let's talk about how to multiply two full-size matrices. So not just rows and columns, but with entire grids. Okay, so first of all, let's try to understand the sizes of these matrices. So let's say we have a matrix A with m rows and n columns, and we have another matrix with n rows and let's say k columns. And now you have to multiply these two matrices together. Okay, the key point is that the number of columns in matrix A must match with the number of rows in uh, matrix B. So this is what makes the multiplication possible. So remember, if you're asked to do the multiplication for two matrices, in order to make the multiplication works, you should have the same number of columns in matrix A with the same number of rows with matrix B. Okay, so the next question is, what will be my results? Because we know that if you multiply a row by a column matrix, you get an answer as single number. But here we don't have row matrices or column matrices. These are just like full size matrices. So uh, if you multiply these two matrices together, you get a result. Let's say the result is C. C is the product of A and B. So for the resulting matrix, you will get m rows with k columns. So this is your results. So your answer will be a matrix of m rows and k columns. So how the next question is, how do we multiply them together? So this is the basic idea. So to find each entry in the resulting matrix, what you have to do is you take a row from matrix A and a column of matrix B, and you multiply the corresponding numbers and then you add them up. So just like you did as a row matrix and a column matrix. So, but now we do it for every row of A and every column of B. For example, let's take two matrices. Let's say we have like A equals 1, 2, 3, 4. So this is a 2 by 2 matrix, which means with two rows and two columns. Another matrix we have is 5, 6, 7, 8. So now let's compute. Let's try to compute the product A and B. So first of all, let's try to multiply the two matrices together. And here, try to understand. So here, the number of the columns in matrix A matches with number of rows in matrix B. Okay, so now let's compute the product A, B. So to find the top left entry, you have to multiply row number 1 from A by the column number 1B. So that means this is the first row of matrix A and this is the first column of matrix B. So you have to multiply corresponding entries of these rows and columns, and then you have to add them together. Okay, so let's try to do that. So if you multiply first entry by 5, you'll get a 5. You have to add this with 2 multiplied by 7, which is going to be 14. So this is your first entry in the product matrix. Next, you are going to multiply the first row of matrix A with the second row or a second column of matrix B. So this will result the top right corner element. So let me multiply that. So if you multiply 1 by 6, you'll get a 6 plus, and then you multiply 2 by 8, which is 16. And then let's try to take the bottom elements. So here you have to multiply the second row with the first column. So 3 by 5, 15 plus 4 by 7, it's a 28. So you have, in order to get the third entry, you have to do it's just 15 plus 28. And then in order to get the bottom right entry, you have to multiply the second row of matrix A with the second column of matrix B. So it's 3 by 6, 18 plus 4 by 8, which is 32. So now let's do the simplification. 5 plus 14, a 19, and 6 plus 16, it's a 22, and then 15 plus 28, 43, 18 plus 32, a 50. So the resulting matrix will also have 2 rows and 2 columns. So this is how you get the product of two matrix. So the quick summary, you can multiply m by n matrix with n by nk matrix. The result will be m by k. So let me write that. So if you are trying to multiply m by n matrix with n by k matrix, so you have a result as m by k. So each entry is found by multiplying row from the first matrix with a row from the column from a second matrix. So let's try some examples. So here you are asked to take the product of two matrices. You have matrix A and B. First of all, you are asked to take the product of A and B. So order matters here. So first I have written matrix A, and the second I have taken matrix B. So both matrices are with two rows and two columns, which means number of rows here will matches the number of columns over here. So number of columns in the first matrix matches with number of rows in the second matrix. So let's do the multiplication. So to get the first entry, you have to multiply the first row with the first column. So if you do so, you'll get 1 by A, it's A plus C. And then to get the top right entry, you have to multiply the first row by the second column. That's going to be B plus 2D. And then to get the bottom left, you multiply second row by the first column, which is 3A plus 4C. This is going to be 3B plus 4D. Okay, so now let's move into B, the product of B and A. In that case, I have written my first matrix B here, and this is my second matrix. And again, the resulting matrix will be a 2 by 2 matrix, which means 2 rows and 2 columns. So here, to get the first entry, you multiply this by this. It's going to be A plus 3B. And then you're multiplying this by this to get the top right entry. So it's 2A plus 4B. 2A plus 4B. So to get the bottom left, you multiply bottom by the left bottom row by the first column, which is C plus 3D. This is 2C plus 4D. And you see that once the order changes, the resulting matrices will also change.